Hi, everybody. So, in the interest of full disclosure, I realized that I had some technical difficulties with a couple of videos. So now I'm going back to re-record a couple of situations or a couple of hours. And I'm going to start with this one and then do the next one. And I had audio problems. So hopefully I don't have any audio problems now. And so, it's not going to be, unfortunately, as exploration as as it could be, because I've done this already and gone past this. Now I'm coming back and I'm going to fill in the gaps. So anyway, I'm going to try to replicate kind of the same kind of flow that I had before, but we'll have to see how that goes. Anyway, where we left off in video 2, and this is going to be video 3, we were just about to do this list test case, and the idea was that we were going to be able to display these lists. And up until now, we've been displaying single values, right? And so we've not had to do very much, because either the debug was going to display the object or the single value, or we created some kind of formatter that would print in a nice way. Well, now we're going to introduce this idea of, well, because it's a list, we need to create some kind of iterator, a loop, over all of the items in the list, or whatever it is we're going to call it here. And so let's have a look at what they do here. So elements must be handled sequentially. It's tricky, sure, why not? Each write generates a result. We require handling all of the results, and so they provide this question mark operator. So if you look at it here, you can say, using question mark on write looks like this. We put a question mark at the end before the semicolon, and this basically says, hey, if there are errors, then stop here and report the error. If there are no errors, carry on. So then they've got it down here where they are doing that same kind of thing, right? So there's the question mark, there's the question mark, and this is inside the iterator. And then here, no question mark, because this is the last result. And so either it's going to that one's either going to return directly an error, or it's going to return the whole result. And all of these writes get stacked up, I guess, and then they all output. So let's create, actually, yeah. So what I'm going to do is I'm going to go back to the code that I had written before and kind of walk through a little bit. Although, no, I'm going to start over again. So let me copy that. Okay, so in Visual Studio Code, what I need to do is I need to create, so let me run a new terminal, and I'm going to change directory to C://rust, and in there I'm going to say cargo new print list. Ooh, that already exists. Okay, because I've done this before. Print list 2. All right. So now let's file open folder in Rust, print list 2, select the folder. Okay, here we go. We've got our source code main, which has the usual stuff. Select all of that, and then paste in the code that we just copied from over there. Okay, and let's just have a look and see what all of this is doing. So it says, hey, we're going to use import the format module, the fmt module, and then we're going to define a structure called list, and that list is going to contain a vec, which I assume is a vector, which is kind of a Java way of saying what C# would call a list. It's a little bit confusing, I guess, if you're trying to look at multiple languages here, because list is a keyword in C#, but here it's just a name of an object. Vec is the keyword, I guess, and yeah, oops. Looks like I just reorganize things, and it's a vector of i32 or int 32s, or in C# or Java, I guess it would just be int. Okay, so, and then once we've defined it, we can implement a format display. So we've got format package, and we're going to implement format display for list. And we need to implement the function format, and I guess fmt. I'm not sure if this is the same fmt as that fmt. No, yes, it is. It's from this package, from this module. There's a formatter in that module. There's a result in that module. But this fmt is different because it's the name of the function. But presumably we're implementing that function because that's one of the functions that's being expected for display. Okay, and so what's going on here? Extract the value using tuple indexing and create a reference to vec. Okay. I don't think we know what a tuple is yet. But we will find out in the next following sections. They describe what a tuple is. So just go with it for now. Okay, and create a reference to vec. So list has a vec, and this 0 is referencing the vec, the whole vector. So it's not the first element of the vector, it's the whole vector that's being referenced here, but with the dot 0. The ampersand is who knows why at this point, because self is an ampersand list, and we want, so by ampersand list, we are referencing the vector. But this is an ampersand vector. Oh dear. So it's a little, I don't know what the heck's going on here. But anyway, we're just going to go with it for now. And so the formatter, F, we're just going to write the square bracket. And here we've got the question mark, because if something goes wrong writing the square bracket, we want to bail on this thing right away and report an error. And then here we've got for loop, and we're saying for count and v in vec iterator enumerate. Then we have to use the, if count is greater than 0, we're going to write the question mark, or write that comma space. So we're using count 0 or count not equals 0 to figure out whether we should put a comma there or not, right? Because we don't want to have a comma when we're formatting the output. We don't want to have a comma at the first spot. So we need some way of figuring out, hey, is this the first one or not? If it's the first one, then let's not put a comma. And if it's anything else after that, put a comma first and then the number. So this is writing the comma space, and then this is writing the number. And again, everybody's got the question mark. And then finally, we close the square bracket. If I delete this, let's see what happens if I delete this. Oh, actually, you know what? Before I do that, let's save this. And let's run this once. And it looks like we're going to populate list with a vector with 1, 2, 3 in it. And presumably, what's going to output is square bracket 1, 2, 3 square bracket. So if we run this, there it is, square bracket 1, 2, 3 square bracket. Okay, cool. So now let's do this again, but let's get rid of the question marks and see what it does. Let's see if we can do that. Save that. Oh, and we're getting errors already. What are we getting? It says this macro accepts. Oh no. Okay, that's fine. That's explaining what write is, but we need to see what the error is. So we're going to scroll down. Here we go. Finally, at the bottom. Unused result that must be used. Okay, this result may be an variant, which should be handled. Okay, so what it's saying is, pretty much what I said before, which is that write can return a useful thing, or it can return an error. And in Rust, I guess, what's happening is we can't just ignore errors. So other languages, we're free to ignore errors, right? So in C# and Java, if something throws an exception, it's cool. Whatever. Somebody will handle it, or the program will crash. No big deal. Something will happen, and eventually somebody will handle the exception. So we can just ignore it. But it would appear here in this language, it's not going to let us do that. We're going to have to handle and deal with the errors. Whoops. I didn't mean to do that. I meant to Control Z. Let's put those question marks back. Okay. So it wouldn't even let us try to run it. The compiler is stopping us from actually, I wonder, is the compiler really stopping us? Whoops. Why? Why? There we go. Got rid of all of the question marks. So we save this, we're getting these, but now if I try to run it, let me try to run it. All right, run. Oh, no. It's, well, although, okay. Actually, it did let us run it, but it gave us all sorts of warnings. Unused result that must be used. Note, warn unused must use is on by default. Oh, so we can turn that off. Interesting. This result may be an error. Warning originates in macro write in nightly builds. Run. Okay. Unused result must be used. Blah blah blah. Okay. All right. Well, that's interesting. What it's saying is that it's going to warn you, but it's not going to enforce it. Interesting. Okay. Well, okay. All right, let's put the question marks back. Well, okay. So the warnings need to be paid attention to. Looks like you can turn them off, but then we're getting back into kind of the standard language issues. All right, but okay, so there's some self-defense here. All right, so now there's a couple of different ways of implementing this counter thing. So I don't know. I mean, we could, let me try doing this. Instead of using count, let's put a Boolean here. And so we'll say let is first equals true. And then we'll set is first to if. Oh, look at the if statement. No brackets. All right. If is first is true. Oh, no. If not is first. We want to write the comma. So if it else, so we want to do an else here. Is first equals false. So the first time through, we're going to so if it's true, then is first will be true. So this is not going to do the comma. It's going to set is first to false. And then every other time, it's going to write the comma. So this is another way of doing it. And we don't need count. So I think we can maybe get rid of this. Whoops. Yeah, like that. Is that going to work? Let's give that a try and see what happens. Save this and run. Whoop. What was the error? Oh. So V is a U size and an int 32. Oh, okay. Okay. Iter. What does iter do? Iter returns I see. Iter next. Okay. Enumerate. Enumerate returns. Oh, it returns both values, I and val. Okay. What can I get? Something that will return me just the value? There's a lot of choices here. Into iter. What's this do? No. Next. So it looks like iter.next is what I want. No. I don't know. So this V, I don't actually want that. I want, all right. You know what? I am going to have a little peek at what I did before, because the code I wrote before. Right. I'm gonna cheat a little here. I'm gonna go back because I did this before, and somehow I managed. All right, let's have a look. Okay, what did I do before? Oh yeah, so for v in vec.iter, which I thought I wanted to do. Okay, all right, let's go back. Did I open Oh, okay, yeah. Let's just go back to here. So so without the enumerate, basically. So that that gives me an I32. So the iterator gives me the I32. Enumerate gave me this extra stuff. So this V, let's see, save. Okay, so that the V is happy now. So for V now becomes an I32 instead of that round bracket count I32 thing, because I got rid of enumerator. And so what's it complaining about here? Cannot assign twice to a mutable variable is first. Oh, right. So this is kind of the, what's it say here? Consider making this binding mutable. Mut is first. Okay. Let's do that. Mut is first. And save that. And now it's happy. However, still complaining about something. What's it complaining about? Should have a snake case name. Quick fix. Rename to is first. Okay. So I guess I am going to use the standard here, this formatting standard. I'm going to use snake case for my variables. So we've got that was my C sharp stuff coming through. Is first is true. Write that. Okay, and then write. And away we go. So if I run this now, oh, I still get 1, 2, 3. Okay, so it still works exactly the same way. So this is, so what they had was one way of doing it with this iterator enumerate thing, and I can do it this other way. All right, let's go back and have a look at what they're asking for us to do. Okay, so let's see. Oh, here we go. Activity. Try changing the program so that the index of each element in the vector is also printed. The new output should look like this. 0, 1, 2. Because, you know, indexes start counting at 0. That's why, you know, count was 0 the first time through and not 1. All right, so let's do that. Now, the easy way to do that would have been to just keep count here, right? Because then we could have just said curly brackets count comma V, and then we're using count in the first place, V in the second place, and with a colon in between to format it, and it's all cool. But let's do, since I've modified this, where'd it go? Where'd you go? Here we go. Since I modified this to use this Boolean, let's do this one. So what we're trying to change is this line right here, right? Because what we want is we want the count colon the value. Okay, so we need to add an extra set of curly brackets here and a colon. Actually, let's not put a space there. Oops. Let's not put a space there. And so we want to say count V, right? Okay, so we don't have a count. So this should give me an error. Yeah, there we go. Count is an error. So cannot find count in this scope. All right, so let's create a new variable here. Now, again, we're going to want to add to count. So we're going to want to make count mutable because we're going to change it, right? Just like we changed is first. So mut count equals 0. We'll start with that. And then what I want to do is every time what are you complaining about? Okay, no longer complaining. There was a red curly under here, yeah, but it's gone. Oh, what's this though? It's yellow. What's the problem? Oh, okay. It's saying variable does not need to be mutable. I'm getting to it. Give me a second. Okay, so what I want to do is I want to increment count after I use it, right? So I want to go 0, and then right after it's being used, I want it to go to 1, so that the next time through the loop, it's a 1, the next time through the loop, it's a 2, and it's, you know, as many times as possible. So, so the simple way to do that is the postfix operator. Let's just save that. And, oh, that's an error. What's this? Rust has no postfix increment operator. Oh, well, see, use plus equals 1 instead. Okay. Well, that's interesting. All right, so this obviously is a common enough problem that they've got a dedicated error message to not just syntax error, but hey, that specific thing that we recognize as potentially valid is not valid. So you'd better, not do that anymore. Okay, so fine. So we'll do count plus equals 1. Save that. Okay, and now it's happy. And for some reason we're underlying the plus equals. I don't know why. The formatter is doing that. But let's run this again. And there we go. Index 0 is 1, index 1 is 2, index 2 is 3. Cool. Alright, so that's kind of it. I think we've kind of extracted all the value we're going to extract from that. Alright, so, but a couple of interesting things here, right? So we had the enumerator, which gave us this other thing that changed the data type of V. So when I said enumerate, not enumerator, enumerate. So now this became this round bracket u size comma I32, ampersand I32. And I'm not sure why it's an ampersand I32 and why this one is not an ampersand u size. That makes no sense to me, but whatever. So that gave us the count and the whatever, the value. So we could do that, or we can make our own. Now, obviously the idea would be that you want to use theirs whenever possible. Right? You don't want to write your own code if you can help it. You want to take advantage of the built-in stuff. So the enumerate is a good thing when we wanted to use that because, because I had to create, in this particular case, I had to create 2 variables. One to keep track of whether first or not, and another one to keep track of the count. Now I could go back, and since I need count anyway, I can get rid of is first and just use my count. But if I do that, then I might as well just use their count. So it's like, so it depends on what's inside this loop and what you want to use things for. Generally speaking, you want to avoid using one variable to have multiple meanings, because inevitably the multiple meanings collide and then you can't tell. If you use 0 to mean not set, and then because it's never 0, and then sometime in the future the requirements of your program change and it can be 0, now you have a problem because 0 can have 2 different meanings, right? It can mean I don't have anything, or I have this specific thing that is 0, and then your code gets ugly. So it's usually a better idea from the beginning to have 2 different values, one and a value specifically to mean nothing here that is outside the range of valid values, or have a separate variable, like in this case. So I have an is first, and then I have a count, and a count counts, and an is first tells me whether it's first or not, and I'm not combining them. And in a simple loop like this, sure, combine them because it's never going to be anything but this simple loop. But just saying in general, in a more complicated environment, it can be dangerous to overload things that way. Anyway, let's move on from this. Okay, so there's that. Let's close this one up. Close window, close folder. All right, let's move on and see what else they have for us. Okay, so we did the activity. Let's move on to the next page. Formatting. So we formatted, specified a format string. So we had the X, we had the O, the octal. The same variable can be formatted differently depending on which argument type is used. Obviously, we've done this before. Formatting functionality is implemented via traits, and there is one trait for each argument type. The most common formatting trait is display. So here we have display, and we're going to now here's something kind of weird. They've thrown in this. So there is ampersand string, now there's ampersand quote static string, and there was ampersand quote string. I'm very confused by all of this. And here, use standard format self formatter display. Now, in the previous one, we just said use standard : format. And it looks like this makes it a little more convenient, because if you look at this, right, there's formatter and there's formatter. But if we go back, look, we just used standard format here, and we had, say, format : display and format : formatter and format : result. So it would appear that if we are more specific in our list in the use statement up here, we can be less specific down here, although we still had to do that for some reason, which let's find out why we're doing that. Okay, so so we have display for city, we have color, and color. Oh, we're doing the debug printing. You can list full list of formatting traits and their argument types in the standard format documentation. Okay, let's see the full list of formatting traits. Let's go have a look. Okay, there's display, debug, octal, lower hex, upper hex, pointer, binary, lower upper exponent, I assume. Okay. So what this means is any type of argument which implements format binary can be formatted with a B. Ah, okay. So if no format is specified, then the format trait used is the display trait. So we want to implement the display trait as a minimum, probably if we don't want to specify anything. But if we want to specify something, if we want to specify one of these in a custom thing, then we need to implement something. So let's go back. And it looks like what we need to implement is, so this implements display. So I guess we can implement binary for city, and then if they said down here, they said, where is it? Oh, here, print city. So if they had :B in here, it would use the binary formatter for city, as opposed to the default format, or the display formatter for city. All right, well, let's have a look at that. I don't understand what all the variations here and why they're doing these variations. It doesn't make any sense to me. All right, so let's copy this. And let's go back. Let's create a new terminal again. And what was it? Oh, cargo. Cargo new. Okay, and now we're going to file, open folder, Rust. Oh, color print too. Oh, it was print color. It was okay that way. Select folder. Select folder. There we go. And then here we've got main, which is again this thing. Select all with select all with a Control A. And did we grab this? I can't remember. Copy. Go back. Control V. There we go. Okay. Let's run this once just to see what happens. Oh, and we're getting some warnings. Warnings. These fields are never used. Okay. Fair enough. But we do color red, green, blue, red, green, blue, red, green, blue. Wow, it's funny that. Why is red? It says red are never used, but oh, because debug printing doesn't count towards using, right? Because I think I remember that. There was a statement of that before that those don't count. So we're going to get the warning about red, green, blue because all we're doing is debug. Okay, so let's have a look. So we have those. So now we have formatter display. So if we say font formatter, is it going to be happy? Save that. It doesn't seem to care. But we didn't have to do that. We didn't have to do that. Okay, now the other question I had is why this one? Oh, we didn't say. Oh, what is this? Oh, we had an error. Unused import. Oh, okay. So it did give us a warning. I didn't see that. So if we do : that, then we're going to get this warning. This is, hey, you didn't use this one because I did actually use it, but I explicitly referenced it here. So then I didn't have to put it in this list. So if I get rid of this one, then now it's happy because I've referenced it. Okay, now this result here, though, is the format result. What if I said comma result? Now, oh, it says it's unused because here, now if I get rid of this, okay, so it's generally happy other than the unused, these things are unused. So I could have done that. I don't know why they, well, maybe, I'm guessing that because result is a pretty generic, oh, what's the problem with self now? Why are you complaining about self? Keep going. Let's get to the bottom where the error exists. Boy, oh boy. Unused imports. Remove the unused import. Really? It's unused. What? I don't understand. It was used. Is it because I added result here that now that one's unused? Okay. As I was saying, I think the issue, and let's just put it back to the way they have it. I think the issue is that result, there's a whole bunch of things, a whole bunch of objects that return result, not just standard format. And so we want to be specific about which result we're talking about. So we're going to be explicit here. Because if we have other things that also have result, then we're going to have a problem, right? It's just going to be ugly because we're going to have issues with the conflict between different result objects. So I think this is the way to keep them straight, is to not bring it in explicitly, or not, not bring it in the using statement explicitly, because eventually if we bring a second use statement with some other thing which also has a definition of result, then there's going to be a conflict, and we're going to have to go back to this version anyway. Okay, so we have name, which is some weird thing about string. And then we have the formatter. We do some latitude, longitude conversion into north, south, east, west. We do the 0.3 degrees thing. And if so the padding. Let me just try this for a second. Am I doing this right? So if I run this, oh yeah, there we go. So I added the 10 to get these things to line up. So we're going to go Dublin, a bunch of spaces, Oslo, more spaces, Vancouver, one space, and then we're going to get these to line up. And I'm going to try to get these to line up as well. So I want to leave 3. Yeah, let's try that. And let's run this. No, that didn't do it. Oh, because I want to write justify. So right now I'm leaving 3 space, but it's not write justified. So I think that, was it that did it? It's been a while. Run. Nope, that didn't do it. What? Oh, hang on. Was it like the... No. I don't remember. I don't remember what the... how to get right padding. Or did I get the arrow in the wrong direction? Nope. What was that? Was that a space in there? No, I don't remember. Oh darn. Okay. Well, you know what? I'm gonna have to go back and reference old code. Let's go back and look at, where did we hide this? So let me go look at oh, I didn't do anything with that. Oh, here it is. 0 angle bracket 6x. Okay. So, but do I really want a 0? I don't want zeros. I want spaces. But I had the angle bracket the right way around. But what I want is I want a space. I don't want 0. Alright, let's try with 0 and make sure that works. No, that doesn't work either. That didn't give me what I wanted. Oh, I know why. Because that's supposed to be 7. Dummy. Because that's the total number of characters. So, yeah, okay. All right. There we go. 0, whatever, 0, 0, 0. Okay. Now let's replace the zeros with spaces. And run that again. There we go. That's what I wanted. So there's the formatted. So it's right justified. The decimal points line up. It's an easier to read table by doing it this way, right? Now, cancel. Actually, really, it turns out that we only go to 90 degrees, right? North and south latitude. It's the east and west, right? 90 degrees north is North Pole, 90 degrees south is South Pole. So it's only 2 digits. So we don't actually need the third digit. So we can go 6 here. And we're doing 7 because you got to count the decimal point. So it's 1, 2, 3, 4, 5, 6, 7 digits. Okay, so if we save that, run that. Okay, there we go. So there's 2 digits. There's the single space after the colon. All right, so we've got. Where'd it go? Where'd you go? Oh, okay. Huh. Oh yeah. There's the name in 10 characters. At least 10 characters. There's the space after the colon. There's the padding of a space to right justify a 6-character number, so it's 1, 2, 3, including the dot, 4, 5, 6, and then percent, and then north or south, and then space, colon, or space, the space, and then 7 digits altogether, 3 at the beginning, 1 for the dot, 3 fractional components, that's 7 altogether, and same thing with the north or east or west. Okay, so it works. Now, my question is, what the heck's up with this static thing here? Like, can't we just say stir? Or ampersand stir? Why does it have to be static? Alright, let's save that. Oh, it complains. What's it complaining about? Consider introducing a named lifetime parameter. And that's what the quote is. Missing lifetime specifier. Alright, so quick fix. Okay. Oh. What? Alright, so that. Missing lifetime specifier. Consider. Alright. Alright, that's. Oh, okay. So that static thing. Was this here before? Alright. So static is some kind of lifetime? Quote static. So the single quote and then some name. So it's not just single quote by itself. It's single quote and then some lifetime. And A was some kind of lifetime that we used before, but it's not happy with this A as this lifetime for something. I don't know what A means. Okay. No, it doesn't. It's not happy. It's use of an undeclared lifetime name A. Oh, okay. So A is not an actual lifetime. A is, so what can I put here? Static is it. Okay, so the only thing I put here is static. Fine. Here we have a lifetime of static. And static usually means never changing. So we populate it and it never updates. Which makes sense in the case of a city, right? If we're populating a structure of city, then we're generally not changing the name of the city. We might adjust its latitude and longitude or something, or the population or something like that. But generally the name is something that is unchanging. Okay, so we do this. We've got the formatting thing happening. We've fiddled with this formatting to make it a little nicer. Now we've got, and so we have our 3 cities. So we populated, and we used an iter. Oh, there's the iter by itself without the enumerate. And then we printed Star City. What the heck? What is Star City? For city in, and city is ampersand city, and there's an array, and stuff. I don't pretend to understand this, what's going on here. Why it's a star city. But we're using star color here. We're passing that in. So what if we get rid of the star? What happens then? Is it complaining? Nothing's complaining. So let's run it. See what happens. Yeah, it ran exactly the same way. So I don't know why it would be star. So it doesn't seem to make any difference to pass in star city versus city. All right, no clue. All right, well, we'll leave it as star, but there doesn't seem to be any functional difference. All right, so color. Switch this to use once you've added an implementation for format display. Okay, let's do that. So how does that go? Impl display for color. Okay, impl this capital D display for color. Okay, and the next thing was we need to implement a format function, and I assume we just want this whole line exactly as is, and add an ending curly brace. Okay, and this says an error because it returns nothing. So, but it's interesting what this says, though. It says found unit type bracket bracket. So it would appear that bracket bracket implicitly returns bracket bracket as its body. So the no return, the void return, if you will, actually returns something. So this is void, I guess. This is the Rust terminology for void, is this pair of round brackets. Okay. So let's do something. So typically we would write okay. So let's do that. Oh, what's the problem? Missing tokens. Oh, because write F the string. That's juvenile. All right, there we go. So let's run this. And there we go. Oh, no. So we forgot to change this. So we're still using the debug here. So we'll get rid of debug. And let's run it again. And this time we have hello, hello, hello. Okay, so if whatever we don't actually have to pay attention to the data that's in there, we can, just do whatever we want. But it kind of makes sense to look at the data. All right, what do they want us to do here? They want us to, here, switch this to, okay. So here, RGB, whatever. Okay, so let's copy this and go back. Go back. And we'll just paste this in here behind a comment to remember what it's supposed to look like. Okay, so what we want to write is, instead of hello, we want to write RGB. And then a space. And then a round bracket. Okay, and then we want to write some stuff. Oh, but again, we want to write some more stuff. So now we need to use that semicolon because we want to write more code, but we want to use question mark semicolon because we want to return an error if there's an error, right? And then we want to write to F, we want to write R, G, and B. So it's self dot So what happened here? So here we said self.lat. So self was city, ampersand city. Then we could say self.lat and self.lawn. So I assume self.red. Can we not say that? Oh, but that's the wrong. We need to go curly brackets self.red. All right, and then let's save that and let's see if this works. Run that. Yeah, it's working. Right, so it's 128, 0, and 0. So let's see, 128, 0, 0. Okay, cool. Okay, so that's functioning properly. So we just need red, green, and blue, comma, curly bracket, comma, curly bracket. We're not gonna. You really can't loop because they're named, right? So we have to kind of just type them out. Okay, and semicolon, and okay. Oh well, and then we need a round bracket to close this off, and so that gives us that and the space. Might as well. And now what we want, oops, end. I'm going to go to end. End. And then we want to, oh right, but we need the question mark. And then we want to write to F. This time we want to write 0x, and then we want to write the hex versions of the three values with no spaces this time. And so let's just make sure this part works. That bracket. Unnecessary. All right, so because this is the last write, we don't need the question mark semicolon business. We can just go right from there. So if we run this now, what we get is right, 128, 255, 90, which is the decimal values. We want the hex values here. So we want to say colon H, I think. Oh no, colon X. Colon X. that. Run that. Okay, so we have 80FF5A, which is pretty close. Although I believe, so this wanted uppercase. So to get uppercase, we need to use the uppercase X. All right. And the other thing is, you can see here, when it's zeros, we're not padding. So we're not sticking in the extra. So again, if we want to do the padding, it's 0 angle bracket 2 in this case, right? Because we want copy, paste, paste. We want all 2 characters, or 2 characters in total, right? And if there aren't 2 characters, we want it to pad with zeros to the right, or to the left side. Right padding or whatever. Anyway, okay, run that. And there we go. Pair of zeros, pair of zeros, pair of zeros, zeros, dum dum, da 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 da. All right, and the last thing we're going to do is we're going to colon space 3. Oh, 3. Because I want these to line up as well. And we run that. Okay, and there we go. 128, do 55, 90, 0, 3, whatever, and there's extra space, and so then these all line up because the 0x's all line up because all this stuff lines up. Okay, so that's a nice organized looking output that we can look at. Makes it easy for people to scan the columns and read what's going on. All right, so that is that. Let's have a look and see what is coming next. So that's formatting. So we did that. Cool. Or that's the zeros. Sure, we could do that. All right, next thing on our list is primitives. We'll get to that next time. All right, thanks for watching, and I'll talk to you later.